Hello guys, welcome to Spark Tech Academy. Now we will be going through dot conventions in inductors in magnetic circuit. Actually in previous lecture we have already gone through what inductors are, what magnetic field is, what magnetic circuits are, how they work. Now we will be going through a series and parallel connection in case of inductor and what is actually the mutual inductance. Now first of all, I will be showing you the series arrangement in case this is L1, this is L2. The same way this is L1 and this is L2. Now, this is the series adding connection and this is series opposition connection. Now, I will explain what actually is the dot convention. The dot convention is that when current enters, when current is entering through these dots which are marked here, if the current is entering from both the dots, means you can say if current enters dot in L1 and current enters, you can say add dot in L2. In this case you can say it is marked as positive and also this is marked as positive. If current leaves, means current enters at dot in L1 as in this case and current is leaving through this dot, current leaves at dot in L2. This is indicated as positive but this is indicated as negative. Whenever these are nothing but the same sign conventions as we have already studied in KVL, KCL, when we are taking the mesh analysis or when we are trying to conduct the path of current through inductor or resistor or capacitor in case of KVL. The same way this is been done, only these dot conventions are marked because we have to concern with. Hello guys, just now we have taken this into consideration, the dot conventions. Now I will be explaining you the series adding connection and series opposing connection. In this case the mutual induction takes into place because the magnetic field created by L1 and magnetic field created by L2 will superimpose or they will interact to each other. That's why if the L1 is creating di1 by dt, the current is opposition to that current, it is nothing but, you can say, only you will see it as I1 of t by L1 actually, and by L2 it will be I2 of t. Now in this case the mutual inductance will be nothing but M will be the turns which have been created, by N2 and Phi2, and this I1 will be present in this case. The same case will be when the other coil creates that thing, it will be N1 into Phi1 divided by I2. This kind of I1 and I2 will be created, and that's why this mutual inductance comes into existence. Now what you will say is that in this series arrangement, as these flux are adding each other, that's why L1 plus L2 plus 2m is present. And already I have explained that dot convention. When dot convention is positive, means current is entering to one dot, and I1 is also entering from that dot connection, and I2 is also entering from dot connection. That's why we are taking it as addition. And when I1 enters in second example, you say in opposition, what happens is I1 is entering at dot connection, but I2 is leaving the dot connection in this case. That's why we are taking it as minus 2m, means opposition in that case. That's why please note down this both the expressions, it is very important. And also note down this mutual inductance effect also, because it will be very helpful to you from point of view of your examination. Now again, one point I want to clear is that one coupling coefficient is present. This coupling coefficient is nothing but k equal to under root L1 by L2. This is nothing but coupling coefficient of these coils L1 and L2. These two inductors are being mutually coupled. That's why that coupling will be given by k equal to m divided by under root L1 by L2. And where when k, the value of k equal to 1 is equal to perfect coupling, you can say perfect coupling. And when value of k is equal to 0, you say no coupling. Please note down it is very important. This is nothing but phi 21 is equal to flux in coil 2 due to current in coil 1. And in same way you can say phi 12 is equal to flux in coil 1 due to current in coil 2. These expressions I have corrected it because from me by mistake it was missing. That's why I have noted it down. The same way is that you can also take this mutual inductance concept in same way. Here the M will be present, L1 and L2. Here the I1, here you can say it is I2. I1 will be producing here the flux phi 21, here the flux phi 12. This is coil 1, this is coil 2. Accordingly, this mutual inductance will, and the turns of coil in this are N2 and this is N1, the number of turns for that coil. And in this way you can find out the M1, that is the actually M2 it is, because M2 will be present because of current 1. That's why and M1 will be can say it as M12 and M21 because where the current will be the main creator which will be creating the flux in next adjacent coil which is being mutually coupled to it. So please thoroughly note it down. Now by using these concepts I will be deriving the equation. Using these concepts I will be deriving the equation in parallel arrangement of inductors. Please note it down. Now you know very well that in parallel connection, first thing you should be knowing in parallel connection what happens is voltage V will be common and current will be divided, means I is equal to I1 plus I2 in parallel connection. These two are basic points which are very important in this case. Now what I will be doing is I will be first taking these voltages. I will be writing the equation for these voltages actually. Now voltage V equal to L1 di1 by dt plus L2 di by dt. In this case mutual inductance will be present, and in same way we will be writing the equation L2 L1 di1 by dt as well as L2 di plus L1 di by dt. In this case it will be now what you will do is that I1 and I2 you know already. This I will be I1 plus I2. In this case di1 by dt is equal to di by dt is equal to di1 by dt plus, it is just the derivation of that. Derivation is nothing but the change of that current. Now while taking this into consideration, one thing you should know, we have to write the equations for this. This is the equation 1 and equation 2. Now for for sake of simplicity we will be writing the derivative, means we will be taking this into matrices because we want to find out the actual expression of parallel connection. Now what I will do is just I will form the matrix here L1 M L2 M. Here you will be writing this di1 by dt di2 by dt is equal to V because these voltages are same in parallel connection. Now what you will do is that you will find out the matrix inverse because we are dealing with the current now. di1 by dt and di2 by dt will be matrix inverse of this matrix inverse of L1m and L2m matrix inverse, and this V will be common in this case. Now I will explain you the basic matrices rule. When A inverse is to be calculated in matrix, 1 upon A determinant it will be there, and if the basic matrix is A, B, C, D, in this case D will be here, A will be here, and this B and C will be of negative sign. This is nothing but the inverse matrix formula when you take the inverse matrix of the same. Now in this case what we will do, the first step is we will take the determinant of inverse matrix. Now inverse matrix is nothing but M, here L1 minus M minus L2. Here one thing is missing actually. The matrix formation, while doing matrix formation, L1 and this is L2. The determinant of this will be L1 into L2 minus M square, and the matrix will look like, means equation will look like L1 L2 minus M square, and this matrix will be L1 minus M L2, and here the V will be present in this equation. Here this is di1 dt, di2 by dt. When we solve this, what we will get as di1 by dt is equal to V L1 minus M divided by L1 L2 minus M square, and other will be V L2 minus M divided by L1 L2 minus M square. Now by solving these two equations we will be getting di by dt equal to di1 by dt plus di2 by dt. Please write it down because I have to now rub the portion. Now, okay. Now in this case, we will be solving further. When we solve further, we get as di by dt equal to, as the addition of both is L1 plus L2 minus 2m divided by L1 L2 minus m square. Now we know everyone, VL is equal to voltage across inductor is nothing but L equivalent di by dt. By substituting di by dt in this equation, you will get as V equal to V L equivalent into V L1 plus L2 minus 2m divided by L1 L2 minus m square. Now in this case, these voltages will get cancelled and you will get L equivalent as L1, just rearranging the equation, L1 L2 minus m square divided by L1 plus L2 minus 2m. This is equation for series adding condition, and L equivalent for opposing condition is same, only here plus 2m will be there. For parallel, sorry, series, this is parallel adding condition and parallel opposition condition. Please note it down very carefully because it is very important derivation. From point of view of your concept, it is very important because no one will go in that detail what the detail I have already given to you in step by step manner, and accordingly please solve it, you will get the equation.